Okay, continuing on with our second example, could we use the interval to estimate the mean amount of time a 9-year-old American spends eating and drinking each day? And explain your answer. Well, the answer is no, we can't. And that's because the population we're studying is Americans aged 15 and older. So 9-year-olds are not part of the population being studied. So anytime we get something outside the category of our sample, in this case, Americans age 15 and older, 9-year-olds are not in that group, so we can't use our confidence interval to estimate the mean eating and drinking time for 9-year-olds. Now let's talk about the minimum sample size to estimate a population mean within a specified margin of error. So the equation for this is a little bit different than the equation for finding the sample size needed for a population proportion. This one is n equals, in parentheses, the critical value, z alpha over 2, times the sample standard deviation divided by the error, and then we square the whole thing. Okay, again, these critical values, just like I explained before for each confidence level, we have, and we really only care about the rightmost critical value. So it gives us the area of alpha over 2 to its right. Remember, there's also an area of alpha over 2 in the left tail. And our confidence level is the area in between the two tails. So I've just reproduced those critical values in the table again for you. It's the exact same table as was in section 9.1. So a researcher wanted to determine the mean number of hours per week, Sunday through Saturday, that the typical person watches television. Results from the Sullivan Statistics Survey 1 indicate that the sample standard deviation is 7.5 hours. How many people are needed to estimate the number of hours people watch television per week within 2 hours? So, again, we have n equals the critical value times the sample standard deviation divided by the margin of error, and then we square that result. So we have the critical value for 95% confidence level is 1.959 963,986. And we're going to multiply that number by the sample standard deviation of 7.5, divide it by the margin of error, which is 2 for this problem, and then square the whole thing. So remember, the word within indicates the margin of error. That's like the key word. So if we put that in the calculator, we would do it like this. 1.959963986. Oops, and I should have put a parentheses in front of that. So you put a parentheses in front of that. If you need to go back and do it, if you hit the second and delete button, it will let you insert something. Now I need to go back to the end. Times 7.5, divide by the error, which is 2, close the parentheses, and then square all of it. So we get 54.02 hours, not hours, sorry, number of people we need to survey. But remember, we always, when we're finding minimum sample size, round up, even if normal rounding rules would say round down. So really, we need 55 people, because this is an always round up situation. Okay, let's do another one. How many people are needed to estimate the number of hours people watch television per week within 1 hour with 95% confidence? So, since our confidence level is the same, our critical value is the same. And remember, we use all the decimal places because it makes our answer more accurate. I'm sorry, that should have been a 9. Our sample standard deviation is the same, 7.5. This time our error is only 1. And if we calculate that, we end up with needing a sample size of 217 people. Now they want to know what the effect of doubling the required accuracy has on the required sample size. So doubling the accuracy is the same thing as having the error. So we started with a margin of error of 2 in the first part of the problem, and in the second part we had a margin of error of 1 hour. So from A to B we halved the margin of error. What happened to the sample size? Well, let's divide 217 by 55. So 217 divided by 55 gives us approximately 3.94. So that means that having the margin of error, or doubling the accuracy, remember those are the same thing, doubling the accuracy quadrupled the required sample size. Quadrupled means multiplied by 4. All right, how many people are needed to estimate the number of hours people watch television per week within 2 hours with 90% confidence? So here, our z alpha over 2 is different because we only have a 90% confidence this time. So it is 1.644853626. Our sample standard deviation is still 7.5. Our error is back to 2 hours. And we need to square all of that. And when we do, we end up with needing a sample size of 39 people. So if we compare the results of Part D to the results from Part A, remember Part A had 95% level of confidence and Part D has 90% level of confidence. What does decreasing the level of confidence do to the sample size? So in Part A, with 95% confidence, we had 55 people. When we decreased the confidence to 90%, we only needed 39 people. So decreasing the level of confidence decreases the required sample size. Well, that is it for Chapter 9 material. Next week, there will be an exam.